All right. So share my entire screen here. On your 4.6 homework, what did we do yesterday? We did 1 through 3. We need to talk about 4 and 5. Yeah? All right. Let me pull up is here. I have it already pulled up. Here is the tree diagram that we can use to answer these questions. Number 4 says, what's the probability that the championship will go to 3 games? Okay, so the probability that the championship will go to 3 games. I'm going to go back here. I want to make sure that I use the correct probability notation. See, the bells are all off. I want to use the correct probability notation. And I'm just going to do 3 games. Like, I don't need to make it super. Oops. When I use notation, there will be one question on the test where I just ask you to write the notation. So make sure you guys just know how to use the notation and what the U and the upside down U stand for. All right. So I need it. How many different ways how many different ways does this series go to 3 games? There's 4. Yeah, there's this way right here, this way, and this way. So in order to answer this question, I need to find the probability of each of those outcomes. Okay, and I just need to use my calculator and multiply. So get your cell phone out or get your calculator out, and let's multiply to figure this out. So this first way is 0.6 times 0.4 times 0.6. What's 0.6 times 0.4 times 0.6? 0.144? Okay. 0.144. Why is this messing up right now?
And internal. It's all about how.
Who is that? I don't know. But I'm about to put the waiting room on since we're already starting. Okay. All right. So that's the first one. Next one. What is 0.6 times 0.4 times 0.4? I think we did that one in the last 0.096. So I got to add that to this probability here, 0.096. Okay, plus. Now I got to do 0.4 times 0.6 times 0.6. Isn't that the same as the first one? Yeah, so it's plus 0.144 again. And isn't the last one going to be the same as the second one? Yeah. So all I got to do is I got to add all those together. Add all 4 of those together to get the answer to this question. And anybody can give me an answer if they have one. 0.48 exactly. Nice and easy answer. Don't forget that the directions are asking you to write all final answers as a percentage. So when you get it as a decimal, multiply by 100. If you're not good at moving the decimal place over, what is 0.48 as a percentage? Just 48%. Good. So there's number, what was this? Number 4? Okay, that was number 4. We had done 1 through 3. I may not have even put in 1 through 3 in the original video either. I don't think I did. I did 1. I don't think I did 2 and 3 in the original video. So using this information, if you're watching this on video, you guys will have to figure out 2 and 3 on your own. based on what we just did. Okay. Do I need to leave this up any longer? Okay. At home any longer? Pretty straightforward. You should have already had the tree diagram, and if you don't, it's in the slides. If you or it's in the first video if you missed yesterday's lesson. Okay. So, do we need to talk about number 5? You want to talk about number? Okay. So we're going number 5. Anybody at home want number 5? Okay. So you guys can do number 5 on your own. Let's talk about the next section. It talks about just different possible combinations of pants, shirts, and shoes that you can wear. Don't forget that the best way to approach these types is figure out how many total possibilities there are. If you count all those, there's 24 different combos. So I would write that off to the side because I can't write right now. There's 24 combinations because every probability question on here is going to be divided by 24 based on that information. Okay, so anybody want to pick out 1 or 2 that I can do in this section? Number 9. All right. Number 9 is the first one that I'll do. Number 9 says, what's the probability that somebody is wearing gray pants and black shoes? Don't forget that symbol means and, not or. So probability of gray pants and black shoes. So I'm looking at here the only gray pants. This is the only possible right here to have gray pants, right? Those are the only ones. And to have black shoes, there are 1, 2, 3, 4. So what's my probability? 4 out of 24. I don't need to do the notation because it's already given to me. The only thing I need, I'll write it over here. So for number 9, the only thing I need to do is 4 out of 24, and then I need to change it to a percentage. Okay. So what's 4 divided by 24, and then multiply by 100? So if I divide that, it's 0.16666 repeating, right? Which is 0.167. And then times 100 means it is 16.7%. Not too bad. Anybody want me to do one from home? Anybody who has a request from home? Anybody else have a request here? I'll do one more in this section. 7. Number 7? Okay. Yeah, 7. Somebody just said 7 at home too. 7 is probably the hardest one, but it's not as hard when you start to realize it. So on number 7, I don't have the notation, so we're going to write the notation. Probability, 2 colors, 2 same color. I'm just going to try to write it as short as possible. So 2 same color. Now, it says at least 2 of the same color. And then we're going to include shoes as an article of clothing here. All right. So all we're going to do is we're going to count up out of the 24 different times, how many different times does 2 articles of clothing show up at the same color? So black, green, black. So there's 1. Black, white, white. There's 2 because there's 2 white. Black, white, black. 3. Black, purple, black. 4. And black, yellow, black. There's 5 so far. And just keep going. Keep counting them. White, green, white. There's another one. 6. White, white, white. 7. White, white, black, 8. White, purple, white, 9. And then white, yellow, white, 10. Green, green, white. There's 11. Green, green, black, 12. Green, white, white, 13. Is that it? Yeah, that's it, right? So there was 13 combinations that had at least 2 clothing items that were the same color. So now that I have my fraction, and get the decimal. And you can just give it to me to 3 decimal places. 542 multiplied by 100, 54.2%. I think you guys can figure out the rest of these on your own later if you haven't finished this yet. Okay, we did 2 of them already. Again, make sure you follow the directions. Notation if it's not given, plus the answer, final answer as a percentage. Okay. What? Which one? No, not on the ones that are already given to you. Only if it's not given to you. Yeah. So like 6, 7, and 8 you do, but not on 9. 9 and 10 you just put the answer. Fraction in the answer. What do you guys think? Is this easier than what we did last week? Should be a little bit easier. Okay. Not too bad. Okay. Next section, let's talk about Zelda. Zelda and Link. Can't believe you guys don't play Legend of Zelda. Boring. You're boring. It was boring watching you sitting on the bench. I'm just kidding. I saw you play. I said your name too. I said your name a lot. Okay. Yeah, your parents always cheered whenever I said your name. It was fun. I want to go over question number 12. Okay, 12. Because it's kind of like a trick question, but it's not really. So question number 12 says, find the probability that Link saves Princess Zelda, given that he defeated the first henchman. Well, first of all, in order to save Zelda, you got to defeat the henchman and defeat Ganon. If you read the prompt, that's how you got to do it. If you play the game, you already knew that. So on number 12, here's what my notation is going to look like. Save Zelda. I'm going to do save Zelda, given that they defeat the henchman. Okay, so that's my notation for number 12. But let's talk about the answer, because the answer is a lot easier than you think. And I want to see if some of you, if you had looked at this already, and maybe if you even haven't looked at it, just look at it now. Probability that somebody saves Zelda, and given that he's already defeated the henchman. So if he already defeated the henchman, that's already done. Think about games that you've played. If you beat a level and you moved on to the next level, well, now you're only worried about what's going forward from you now, right? So he's already defeated the henchman. He doesn't have to do. He's already at that stage where he's fighting Ganon. Now, what's the probability that he's going to save Zelda? Well, the answer's already on the paper. It's just 35%. You didn't have to do any work on this problem. You just had to know what you were looking for. So this is kind of like what I had given you in the example yesterday with the the tennis, making the first serve and then winning the point. Like, it was already given to you. You don't have to worry about doing any math or doing any work. And I think that you can answer 11 and 13 on your own too, as well. Let's go to the last section. And since this is being recorded, I'm going to go back and put in the tree diagram that we drew yesterday. This told us that there were, as a GRE or prep course, there was 30% of people that took the course. If they took the course, 60% passed. If they did not take the course, only 20% passed. I think we did it in this class. I didn't do this with every class, but in this class, I think we did it yesterday. So bear with me, guys. You can either, whoops, I don't know why this writing is doing bad today. You can either take the course, not take course. There was a 30% of people took it, while only 70% which means that 70% did not take it. Guys, when you're drawing a tree diagram, always use the decimal version of the percentage, because when you want to multiply to figure out probability, you want to use the decimal version, okay? After you take the course, you take the test, and you can either pass it or you can fail it. It says in the prompt that if they take the course, 60% pass. So that's 0.60, which means that 40% failed. Even if you didn't take the course, you can either pass the test or fail it. And again, in the prompt, it says that if they didn't take the course, only 20% passed. Obviously, taking the course is helping people pass this test. Did you do what I asked you guys to do yesterday? Did you multiply and find every probability? Because if you did, you realize, hey, those answers come by really, really easily. Okay? So if you haven't done that yet, do that right now. Let's figure out what the probability is at the end of each outcome just by multiplying. Grab your calculator. You can make all these calculations in 30 seconds. What's 0.3 times 0.6? 0.18. So just write that off to the side. We know there's an 18% chance of taking the course and passing the test. 18%. What's 0.3 times 0.4? 12%. So I'm going to just put 0.12. What's 0.7 times 0.2? 0.14. Whoops, I wrote that kind of janky. And then 0.7 times 0.8 is 0.56. Now, if you do that, you realize that these questions are super, super easy, okay? On number 16, what's the probability that somebody passed the test? Well, they passed the test here and here. What do I do with those two percentages? Just add them together. Add them together and write your final answer as a percentage. So multiply by 100 after you add them. So 0.18 plus 0.14 gives you 0.32, which is 32%. You can show your work. I won't write it down there on there. You guys can. These are real easy now. They're real easy. Once you multiply to get this at the end of each outcome, but you add if I want to figure out like the probability of them passing. And the same thing's going to happen for number 17 to fail. You got to add in the 2 times that they fail. Because what happens if you add up all of these percentages? It equals 100%. In this case, since they're decimal, it'll equal 1, which is 100%. Okay. Does anybody have any questions about any of those last couple? Because I can do some of those, or I can do one if you need me to. And the answers are already there. Anybody at home want me to do any question on any of the last couple? 19? Question number 19, and somebody asked for 20. So those are the last two that I'll do. Number 19 says, what's the probability that somebody did not review? What does that mean? And pass the GRE. So this means and. So did not review, so did not take the course and pass the GRE. So this is the path. Watch this. Did not take the course, but they still passed. Answer is already there. We already multiplied and figured that answer out. So the answer for number 19 is just 14%. We already figured it out by finding those 4 outcomes.
Not passed.
Yeah. It said did not review and passed. Yeah. Now somebody at home asked for number 20. Number 20 is kind of like that number 12 that I did, where it says, what's the probability that somebody failed given that they didn't review? So they didn't review. This is already done. What percentage failed after the ones that didn't review? 80%. The answer is just that 80%, because when that given sign is there, that means that this already happened. This did not review already happened. So if they did not review, then 80% of them failed. Okay. So that's what that symbol means, and that's how you interpret it from that. You guys good on this worksheet then? You guys have until midnight to turn this in. So if there's a couple that you haven't finished, you guys can kind of finish it a little bit later, probably during advisory too. So here's how you're going to earn your free 100. So this obviously will give you most of the answers for this one. Okay, here's the free 100 that I'm going to go over. Anybody, can I clear this out, guys at home? You good with this? Okay. I have a short thing that I want to go over. It's take me about 10 to 15 minutes at the most. You don't need to take any notes. I just want you to follow along because there's really nothing new about this. What I'm going to go over is what you were going to do basically if we were in a non-pandemic year. I hate the fact that we are not going to have that carnival like we normally do with the little kids, but I'm going to just kind of briefly go over. And then, again, I just want you to follow along. So all you got to do is follow along to earn a 100 for today. All right. And if you're watching later on the thing, you can still get the 100 as well. Once this starts to load. So in a previous assignment, in a previous lesson, I had you guys look up the definition of theoretical probability. And most of you guys gave me the correct definition. Some of you gave me a really long, you copied from the internet. All right, whatever. The easiest way of thinking about theoretical probability is what do we expect is going to happen? How do casinos and how do carnival people, how does Six Flags with those carnival games know how much money they're expected to make on some of these games? And how do they tweak them so that they do make a profit off of it? So I'm going to show you guys what's called expected value. Those carnival games or those casino games that I showed you guys the other day, the casino knows the odds. They know the probability of each of the games that they put in. So they know if they know how many people are coming by and playing, they know about how much money they're going to make. They always win. Casinos always win. Okay. And so you're going to make one basic calculation. When you're finding percentages, when you know what percentages are, you can figure out how many people are expected to win, which in turn means you can figure out how much money you're expected to make. I'm going to show you the example of what we would have done by using a carnival game. You ever been to a carnival game or even at Six Flags and play one of those games where you had to toss a ball into a hole? Okay. Football into a hole, shooting something down. There's a lot of different carnival games out there. And usually we have some really creative stuff every year. Suppose that we have a football throwing game. There's 2 holes on the thing. You can see the screen there. You can see the picture on there. And students spent $57 buying out everything they needed to set up this game. All right. That $57 is important. Remember that $57. Okay. You don't need to write anything down. Like I said, just pay attention. Here are the rules. It's $3 to play. Okay. $3 to play the game. And you have 2 tries to make it in one of the holes. It doesn't matter which hole you make it in. You just get 2 tries, 2 throws. Is that fair? No, it's not fair? Carnival games are expensive. Have you ever done the ones at Six Flags? You pay like $5 for like 3 throws. Like it's expensive. Here's what you can win. If you don't make anything, you get nothing. That sucks. If you make one of them, doesn't matter which hole, you get a small stuffed animal. And if you make both of them, then doesn't matter which holes, then you get a football. Okay, you get to keep a nice, cool football. However, the people that made the game have to buy those prizes. Those prizes are going to cost them something. And so here's how much it costs the game makers. It costs the students $1.50 to buy each individual stuffed animal and $4 to buy each football. Okay, so they have looked at the history of this game or they played it themselves, and they're expecting that people make it in a hole 45% of the time. Now it's probably a little high than normal. We'll just say that this is a little kids game and they're really close, okay, and the holes are big. But we can figure out based on history that about 45% of the time they make it to the hole. So I'm going to create a tree diagram for that. When I toss the ball, what are my only two possible outcomes? You make it in or you miss it. Literally, there's nothing else. You either make it in one of the holes or you miss it. So for simplicity purposes, that's all I put in my first toss. And I know that based on the last slide, 45% of the time, 0.45, they make it, which means 55% of the time they miss it. Make sense? Okay. How many tosses do I get? Two tosses. What are the outcomes of my second toss? Make it or miss it. Do I get a second toss even if I miss the first one? Yeah, because you can still win that stuffed animal if you make one, right? So my tree branches out like this so far. Okay, and I got the same probabilities. Each individual toss is 45% chance of making it, according to the history and the data. Am I going too fast for anybody? Does this all make sense so far? This is nothing new. We just did this yesterday. Okay, we just did this yesterday. Guys at home, you guys still with me? Give me some thumbs up or something. Do y'all know how to do the thumbs up on your Zoom? Thanks, Richard. All right. I labeled each of these with its event. Okay, you can either win a football, you can win a stuffed animal, or you can come away with nothing. Okay, let's hope that we're not coming away with anything. We want to come away with something. There's only one way to win a football. You got to get both of them. But there's two ways to win a stuffed animal. You can make the first and miss the second, or you can miss the first and make the second. Two different ways. And if I wanted to find the probabilities of each one of these things, what would I do with the numbers on the branches? Multiply them. And I'm just going to do them really quick because you guys had just done this. We just did this, and I don't need to have you guys write it down. I just want you to guys follow along. All right. So there is a 20% chance, 20.25% chance to win a football. What's the probability of winning a stuffed animal? Just 24.75? No, you got to add these two. So this plus this, so this times 2 really is the probability of winning a stuffed animal. Makes sense to everybody? Okay. And then there's a little more than 30% chance that you're just going to come away with nothing. All right. So this is how I would figure out how much money I'm expected to make if I were running this carnival game. If I was running this carnival game, this is how much money I would expect to make. Okay. Let's suppose, we have to suppose how many people are going to play. Let's suppose 250 people play the game. How much money can you expect to make? We're going to use this information to maybe tweak our game and see if we're going to make enough money or not. Obviously, if I was a maker of this game, I want to make my no prize a high, right? I don't want to give away a lot of prizes, but you don't want to make it too hard. If you make your carnival game too hard, what happens? Nobody's going to play it. It happens every year. I've been doing the carnival with the little kids for 7 years now. Yeah, 7 years now. And I swear there's people all the time, there's students that make these games and they're like, oh, well, we don't want to give away a lot of prizes because I have them buy candy or whatever to give stuff away. And I'm like, if you don't make your game easier, the kids are not going to want to play. And sure enough, they stay away from the games that are too hard to play. And then they always want to go to the games that have the best prizes. And sometimes people go overboard. Like the year that somebody gave away like ice cream, somebody came in with a cooler full of those little ice creams. Oh my god, dude! And those elementary teachers got so mad at me because they're like they were so hopped up on sugar, like it was crazy. All right. Anyway, so how do I figure out how much money I'm going to make? It's pretty simple. We're going to use those percentages. Watch this. There's three different things that can happen. I can win a football, I can win a small stuffed animal, or I can win nothing. If you remember back on this screen, there's a 20.25% chance of winning a football. All that means is I want to find 20.25% of 250 people. How do I do that? How do I find 20.25% of 250 people? Not divide. I take the decimal version and I multiply it by 250. So if I want to find 20.25%, I take the decimal version of the percentage and I multiply it by what I'm looking for. Always multiply. So watch this. I know it's 20.25% chance of winning a football. I'm expecting 250 people to play. I multiply that out and I get this number. We're talking about number of people. Which way should I round? Just go up. So I'm expecting about 51 people to win a football. That makes sense, everybody. I use the probability from the tree that you guys have already done, and I multiplied it by how many people I'm expecting to play. So I'm expecting 51 people to win a football. Can I do that same process to figure out how many people I expect to win a stuffed animal? Absolutely. I can take the probability of winning a stuffed animal, but remember there are two ways to do that, so I multiply it by 2, and then multiply it by 250 people are expecting to play. I ended up getting about 124 people expecting to win a small stuffed animal. All right. And then, of course, I can do it the same thing for the no prize. About 76 people are not going to win anything. Okay. Is this what's actually going to happen? No. This is not what's actually going to happen, but it's pretty close. It's going to be expected, what we expect to happen. And according to the law of large numbers, the more and more we do this, the closer it's actually going to get to this outcome. We know that based on the law of large numbers. All right. So then I can just figure out how much it's going to cost me. If you remember back from the first slide, footballs were $4. Okay. So 51 people win times $4. That's $204 I have to spend on footballs. Now I know how much footballs I need to go spend on. Now I know how much money on stuffed animals I need to go spend on. They were $1.50. I'm going to give away 124. I got to figure out those in my expenses in my budget when I'm setting up this game. If you're a carnival maker, how much is no prize going to cost me? Nothing. Yeah, I get away free on that one. And so that's not going to cost me anything. And you're running a business. Okay, so you're running a business. Your business is this carnival game. Now I can figure out how much money I'm expected to make. First thing I want to figure out, how much how much revenue am I going to bring in? Revenue in a business is everything that you sell, not including the things that you have to spend to run that business. So everything that you sell in the business is your revenue. If 250 people are going to play and the game costs $3 to play, that's $750 I'm expected to bring in revenue. $750 expected dollars in revenue. Good. Then I just add up. When you're running a business, you have expenses that you have to spend. What are the expenses in this particular case? All the prizes. Plus, if you remember back from the beginning, there was $57 originally to set up everything else. So I needed to buy the original game and all that stuff. That cost $57. All the money in the footballs I got to spend. All the money in the stuffed animals I got to spend. Add all those together. These are all my expenses. Okay. So I have revenue I'm bringing in, expenses I got to spend. How do I figure out how much profit? Just subtract. Revenue minus expenses is always equal to profit. So I'm expected to profit $303 on this carnival game. And if we were to do this carnival like we have done in the past, you guys would have done this. You would have figured out, you would have made your game. You would have figured out how many kids were expected to win, how much money you were expected to make if you were to charge it for it. You don't charge little kids as much as you guys want to. We don't charge little kids. How much you expected to bring in, and then after the carnival day is up, you figure out how much you actually did. That is a actual probability. Okay, so I don't think this is hard, and I'm not assigning you guys an assignment on this because it is on your review already. Okay, so it'll be just all encompassing on the review. Good. Thanks for coming to my TED Talk. All right, don't log off yet, guys, because I haven't taken attendance for you guys. So don't log off yet. All right. This is already, if you want to go back and review this, especially for those questions on the review, this is already in that assignment. Everybody that came to class today, I'll give everybody that came and logged in, I'll give 100 and that we're here. So let me tell you about extra credit. I'm going to update grades tomorrow. There is not going to be a virtual class tomorrow. It's a virtual day, but all you guys got to do for my class is work on your review. Okay. I posted the review already. And just like last time, the review is going to be extra credit, but it's a lot more extra credit this time. There's 33 questions. I'm giving you 3 points per question. So this will place 100 for a missing daily grade. So one missing daily grade completed. Not only will you get that replaced, but it'll also get you ready for the test. Okay. Somebody in my last class was asked. So remember we talked about this yesterday. We're going to review on Tuesday whatever questions you guys have. First half of class, we'll go to lunch, and then right after lunch, we'll take the test. Okay, it's split in half. The test doesn't take very long, 30 minutes tops. It should take you 30 minutes tops to take the test. Okay.
That's Tuesday.
That's Tuesday. A couple of people have asked about maybe doing a review session tomorrow. How many of you would want to come do a review session on Zoom tomorrow? I would only do one session. Anybody? No? Okay. Well, there's a couple of people have asked, so I might do it anyway, and I'll send it out if you guys want to log in. Okay, we'll go over some of the questions on the review. Okay. You do not need to do anything for 4.7 if you were here today. I'm going to post the Ed Puzzle for other people later, but you don't need to do anything in person. Hold on, guys at home. Does anybody at home have any questions? Don't log off yet because I have not taken